Welcome to qnawire.
All right, guys, we're doing problem 110 of chapter 8 in Chemistry Essential Science. So ammonium chloride, NH4Cl, is soluble in water. Draw the Lewis structure of the ammonium and chloride ions. So we're going to have ammonium like this. And this is going to have a positive charge. And this is going to interact with our chlorine, which has a negative charge. And our chlorine is going to have a full octet of electrons. So B, is there an NCl bond in solid ammonium chloride? Well, no, because it's not like you're forming a covalent bond between the nitrogen and the chlorine in ammonium chloride. It's just electrostatic interactions between the entire ammonium ion and the entire chloride ion. So, part C, if you dissolve 14 grams of ammonium chloride, in 500 milliliters of water, what is the molar concentration of the solution? So we have to convert grams to mole. So the molecular weight of ammonium chloride. Mass, that's 53.91. And 491 grams per mole. That's going to give us moles. And then we have to divide that by the entire volume in liters. So that's going to be 0.500 liters. So that's going to be 0.523 molar. How many grams of silver nitrate you need to add solution to precipitate all of the chloride as silver chloride? Right. So we're going to have to so we're going to look at the KSP of silver chloride. Silver chloride is the KSP. KSP of silver chloride is 1.8 times 10 to negative 10. Sorry, 10 to the 10 to negative 10. So remember KSP is going to be equal to Ag plus Cl minus so the minimum concentration of silver is going to equal KSP over Cl minus. We assume in silver nitrate that's very soluble, so you're going to have a 1-to-1 ratio of silver to silver nitrate. So the amount of silver we have to add, in fact, let's just write this as concentration of silver is going to equal concentration of silver nitrate. Silver nitrate 8 is 1.8 times 10 to the negative 10 over 0.523. So AgNO3 1.8 times 10 to negative 10 divided by 0.523. So the amount of concentration of silver nitrate we need. That's going to be 3.4 times 10 to negative 10 and molar. So we're going to convert that to grams. So 500 liter, so 0.5 liters, so 3.44 times 10 to the negative 10 liters, 10 molar, times 0.50 liters. Then we got to multiply that by molecular weight. So multiply that by 169.87 grams per mole. Per mole, so that's going to be equal to 2.92 times 10 to the negative 8 grams. So like we would need an extremely small amount of silver to actually precipitate all of the chloride as silver chloride. Right. And let me just clarify in this case. So this is the concentration of ammonium chloride, and when ammonium chloride is going to readily dissolve, so that's going to equal the concentration of chloride. That's why we could use it like this. So it's a way to understand the solubility rules that we have. We have to work with our solubility rules. We have to understand KSP. We have to understand concentration. We have to understand all these factors in order to solve this problem.